Okay, so now I will be discussing questions related to integration. Okay, so this is from the 2018 October November paper. So the integration question number 8. Okay, so they are asking in Roman number 1, find the integration of x sin x. So when you see integration of x sin x, okay, how does that work? So when you see this particular integration with this product, immediately you need to realize that you are going to use integration by parts, integration by parts. So in integration by parts, the rule that we learn in the textbook is integration of u v dash. With respect to x is u v minus integration v u dash. This is the rule that we are going to use. Okay, so basically, how do you choose u and v dash? When you have the two terms, x is also, x can be differentiated, x can be integrated. Sin x is also differentiate, we can differentiate, we can integrate. So then how do you correctly choose u and v dash? So u is the person that when you, if you continuously differentiate, if the person that first reaches 0 is your u. So you can see here when I differentiate x continuously, it becomes 0. X differentiation is 1, 1 differentiation is 0. When you continuously differentiate. Sin x differentiation is cos x, again cos x differentiation is minus sin x, again minus sin x differentiation. You can see it's a cycle. So then in that case, the first person who first becomes 0 when you continuously differentiate can be your u. Okay, so these are theories that you will learn. And this is the v dash. Okay, so that theory is only applied when both terms are integratable and differentiable. Okay, so in here, because we have a choice. Okay, when there's a choice, this is how we choose. Okay, so then let's use the rule. Okay, and then u is x, u dash is 1, v dash is sin x. Can I know what is the integration of sin x? Sin x integration is negative cos x, isn't it? Sin x integration is negative cos x. So shall we go for the integration of x sin x? So substitute the value is uv. So u is x, v is minus cos x. So u into v minus integration v, u dash is 1. So you get here negative x cos x minus minus is plus integration of cos x. I didn't integrate yet, so I was just simplifying. Minus x cos x minus minus is plus integration of cos x. Now you can see I can immediately integrate the cos x. Cos x integration is directly sin x. Okay, so these are rules in the textbook. These are rules given in the formula book. You can check it out. Then in the next part, we have Roman number, this is Roman number 1, Roman number 2. Use the substitution x equals sec theta. Use the substitution x equals sec theta to show that the integration, to show that when you integrate root 1 minus 1 over x square with respect to x, you can convert it with, you can write it as integration of tan square theta with respect to theta in this manner. Okay, so you just need to do the conversion. Okay, so whenever they give you a substitution, what's the first thing we do? We must differentiate the given substitution. So what happens here? Dx by d theta equals sec differentiation is sec theta tan theta, isn't it? Sec theta tan theta. Dx differentiation is dx by d theta. I'm differentiating with respect to theta. And sec differentiation is sec theta tan theta. So I can get the replacement for dx. So dx is sec theta tan theta d theta. Okay, because our task is to integrate this particular function. So we need to completely eliminate x in this entire equation and get the answer, I mean, convert it entirely into theta. Okay, so dx substitution is found. You even need to get the substitutions for 1 and 2, the limits, the limits 1 and 2 are x limits. You have to convert them to theta limits. So here, when x equals 1, so how do you get the theta value? You know, x is equal to sec theta. So 1 is equal to sec theta. You know, sec is 1 over cos, which means cos theta equals 1. What is cos inverse of 1? Where do you get cos 1? You get cos 1 is 0, right? Cos graph reaches 1 at 0. Do you agree? And then the other one, when x is 1, we get theta is 0. And when x is 2, 2 equals sec theta. Sec theta is 1 over cos, or you could say the cos theta is half, which gives me theta equals what? Cos inverse of half is pi over 3, isn't it? You can type in the calculator in radian mode, or you should remember this because you've been something that is that you've been using a lot, isn't it? So cos inverse half is pi over 3. Do you agree? So after you find the replacements for your x limits, now it's time to substitute in the main equation. So I get here integration. We are supposed to integrate root 1 minus 1 over x square with respect to x. Your limits are from 1 to 2. Okay, so now let's do the conversion. I'm going to write this entire sum in terms of theta. Okay, so 1 minus, okay, so integration, the integration limits, starting x limit 1, the theta limit is 0. And when x is 2, the upper limit x is 2 is theta equal pi over 3. And this becomes 1 minus 1 over x is sec theta. So x square will be sec square theta. Do you agree with me? So I'm replacing everything here. I replace the x here. And then the next one, dx. The dx, you can see I have written the substitution. Dx is, okay, this is outside the root. Dx is sec theta tan theta d theta. Okay, do you agree with me? Okay, so let's substitute. So from 0 to pi over 3 root 1 minus, 1 over sec is cos. So 1 over sec square is cos square theta into sec theta tan theta d theta. So what do we know about 1 minus cos square? So, we have our most used identity here, isn't it? You know the rule, sine square theta plus cos square theta equals 1, isn't it? Sine square theta plus cos square theta equals 1. So 1 minus cos square theta is what? If sine square theta plus cos square theta equals 1, 1 minus cos square is sine square theta. Do you agree with me? And then let's simplify. Sec theta is 1 over cos theta. Tan theta is sine over cos. Let's just have everything ready to see what's going on. Okay, and then let's simplify now. Square root of sine square. So you can see you have power here. The square root and the power 2 will cancel out. So you get sine theta into 1 over cos theta into sine theta over cos theta. Basically, I think I'm creating two pairs of tan here. Can you see you have a sine over cos here and another sine over cos here. So it's tan theta into tan theta. I think the show that here was to get tan square. Yeah. So the show that here is to get the tan square. So in that case, since the show that involves tan, maybe you don't need to write sine tan as sine over cos because the show that involves a tan product. So keep the tan theta. Don't go to write it as sine over cos because we need tan theta in the final answer. Okay, so you better keep the tan as it is and then work with the sec theta as 1 over cos. Square root of sine square, you remove you remove the power 2 with the power half. So sine into 1 over cos, that's tan. So that gives us what? Tan into tan is tan square theta d theta. And this is the show that. Can you see I get the show that? So this is the answer for part Roman number 2, part A for 3 marks. Okay, so this is part A. Then Roman number 2, part 3. Hence, find the exact value of integration of 1 over root 1 minus 1 over x square. So how do we do that? So now we don't go work with this. We work with the answer that we found in part A. Okay, so let's continue the integration. How do we integrate tan square? Do we know how to directly integrate tan square? So I think if you look at the integration rules in the textbook, if you look at the rules that I have given to you, I think you will see. Yeah, so you can see these are the general integration rules that I've taken. So what do we know here? Yeah, so you can see here we know to integrate what? Do we have integration of tan square? So in the general rules of integration, you can see we know how to integrate sec square. Okay, we know how to integrate sec square. Okay, but we do not have tan square. So what we can do is we can use another identity. We can use another identity that is commonly used. What is it? Other than sine square plus cos square equal 1, you know, in trigonometry, we also have 1 plus tan square theta equals sec square. Can you remember? 1 plus tan square theta equals sec square. So this is another main identity that we use in trigonometry, isn't it? So then from this I can create tan square theta is sec square theta minus 1. Do you realize what's going on? So then when we have sec square, we know how to directly integrate sec square. So then when I work here, I go with integration. Instead of tan square, I will write sec square theta minus 1. D theta limits are from 0 to pi over 3. Do you realize what's going on here? Okay, and now I can go with the integration rules. Okay, so let's integrate sec square integration. So sec square into, now here I have written ax plus b to show a linear function. So here it's simply theta or just sec square x. Okay, so then it's going to be, we don't have any coefficient with the theta here. So then this a value will be 1. So it's directly tan x or directly tan theta here. So tan theta minus integration of 1 with respect to theta is theta. Substitute the limit 0 to pi over 3 and you get your answer. So we get here tan pi over 3 minus pi over 3. That's the first limit. Minus the next one is tan 0 is 0, right? And theta is 0. That's a 0. So that entire term is a 0. So I'm remaining here. What is tan pi over 3? Tan pi over 3 in radian mode. Type it in the cal. Tan pi over 3 will be root 3. Root 3 minus pi over 3. So this is the exact answer. I think they wanted you to find the exact answer, right? Hence find the exact value of this integration. So this is the exact value of the integration. Okay.